Hey, this is Mr. Janes. In this video, we'll be reviewing how to graph and some other fundamental skills from Algebra 1. In each section, I will show you how to do the first problem all the way out with the work and the solution. But the remaining problems, I will simply ask you to pause the video and try those on your own. Once you pause the video, the answers will come up on the screen, but not the work to get there. So it's important that you're paying attention and trying to fill in that work to get to the correct answer. Let's start by looking at 1 through 4. Find the slope of the line through each pair of points. Now slope, what do you remember about slope? Well, fundamentally, slope is the change in one variable, often we call that y, over the change in another variable, often we call that x, so the change in y over the change in x. Now you might also remember slope from a graph. We often call that rise, which is the change in y, up and down, over the run, the change in x, or the kind of left to right change. Sometimes we can also use a slope formula, right? So we've written that y2 minus y1, again it's all about this difference or the change in the y values, over x2 minus x1, again that's the change or the difference in the x values. Now in this problem we do not have a graph in front of us, so rise over run will not be very effective. However, the other two methods I will show you right now. If you're looking for the change in y over change in x, the slope between these 2 points, we can literally find the change or how far it is between the y coordinates and the x coordinates. Let me show you what I mean. So from negative 10 to 10, what's the change? What's the difference between those? Well, from negative 10 to 10, I'm adding 20. I'm going up by 20. And from 15 to 7, what's going on there? From 15 to 7, looks like I'm decreasing. I'm going down by 8. So it's a change of negative 8. So my slope could be interpreted as the change in y is 20. The change in x is negative 8. So that's my slope. Now it's often nice to reduce our fractions, to simplify them a little bit. So let's see, both 20 and negative 8 can be divided by 4. So if we divide both the numerator and the denominator by 4, we end up with a slope of 5 over 2, and we have a positive number divided by a negative number, so negative 5 over 2. That is the slope between those 2 points. You could also use the second method here, or I should say the third method, which is to use the formula. When doing this method, we can go ahead and label our points. So we have x1, y1, x2, y2. Again, all the coordinates are x then y. And we can just substitute those right into our formula. So we have 10. y1 is negative 10, so minus negative 10. Really, that's like 10 plus 10. Over, let's see, x2 is 7 minus x1 is 15. So 10 minus negative 10, well, subtracting negative is like adding. So 10 plus 10 is 20. And then 7 minus 15 is negative 8. And hey, look, that's the same thing we got before. Really, these are all the same method, just presented different ways. And again, it simplifies to negative 5 over 2. So either way, you get the slope of negative 5 over 2. The video and try to answer questions 2, 3, and 4 on your own. Using either of these methods that I've shown you is fine. Go ahead, pause the video now. The answers will be up on the screen in 3, 2, make sure you actually paused. Here are the answers. And here are the answers. Some quick notes. For number 2, you may have gotten an answer such as negative 8 over 1. Now remember, when we're dividing by 1, well, any number divided by 1 is just the same as that number. So negative 8 divided by 1, or negative 8 over 1, is going to be equal to just negative 8. For 3, you may have gotten something such as, let's see, could have been 12 over 0. Now remember, we cannot divide something by 0 for a number of different reasons. One of them being, how many times does 12 go into 0? Well, that's not defined in our number system. So you're going to have a slope of undefined. Furthermore, if you have 2 points where the x values do not change, it's going to be a vertical line, again, with that slope of undefined. And for 4, you probably got something to the effect of 0 divided by negative 9 is a slope. Remember, 0 divided by negative 9, or really 0 divided by anything is going to be 0, right? How many times can we, if we break 0 into negative 9 parts, that's still 0. Again, if we have 2 points that have the same y value, I mean, think about that. That's going to be this kind of horizontal line with no steepness, no slope, and so 0 makes sense there. As I mentioned before, though, please make sure you have all of the work out for these. Whether or not you're going to do the change method, or you're going to write some sort of formula here, right? You should have some sort of work for every single question on this page. Let's go ahead and look at 5, 6, 7, and 8. The directions ask us to sketch the graph of each line. Now, in 5, 6, 7, and 8, all of the equations are in what we call slope-intercept form. That means that they look something like this. Y equals mx plus b, where m gives us the slope of each line, and b gives us the y-intercept. Looking at number 5, we have y equals 3x minus 5. So let's see. Negative 5 will be my y-intercept, so I will plot a point on the y-axis at negative 5. Again, we know this number is the y-intercept because on the y-axis right here, x is 0, right? X is 0. So if we plugged in 0, or we substituted 0 in for x, all that would be left was this y-intercept, right? Which is again why our y-intercept is negative 5. Now what about the slope? Well, the slope can tell us where all the other points on this graph will be. The slope is often written as a fraction, rise over run. So if looking at this number 3, you can think of that as 3 over 1. So if I start at my y-intercept and go up 3, remember rise is 3, 1, 2, 3, and over 1, I can get to the next point on my graph. Again, 3 is my rise, and 1 is my run. And I could continue that pattern, again, because the linear equations have a constant slope. And then I can go ahead and graph my line. Okay? And I want my line to not just go through those points, but extend all the way. So make sure you take out a ruler. And this line continues on forever in both directions, so make sure you add arrows to both sides as well. At this point, please pause the video and try problem 6, 7, and 8 on your own. Make sure that you're looking carefully at what the slope and the y-intercept is for each one. The answers will be up in 3, 2, make sure you've paused. Please make sure you're trying these yourselves. And here are the answers. All right, in 6 we've got our y-intercept of negative 3 and our slope of, let's see, down 2, again because it's negative, so down 2 over 5 to get to our next point, right? All right. For 7, well, you might have messed up 7 because, well, there's no y-intercept here, but in fact there is. Remember, we can always write plus 0 on any equation, and it doesn't change the value of that equation. So your y-intercept in this case is 0, and your slope is negative 2/5. Hey, it's actually the same slope there was in problem 6. So again, going down by 2 and to the right by 5. So negative 2 over 5. And in 8, well, you might have gotten a little messed up on this one because there's in fact no slope. But there is a slope, right? If we have y equals 0x plus 2, right, we technically wouldn't have to write the 0x because 0 times anything, including x, is just 0, and it's not necessary to write that in the equation. It doesn't even change the value of the equation. So here, your slope is 0, and your y-intercept is 2. So there's 2, and I guess your slope is 0, so it's a nice flat line. Let's look at numbers 9 and 10. Write the slope-intercept form of the equation of each line. Remember, slope-intercept form looks like this. Y equals mx plus b, where m is the slope and b is the y-intercept. So looking at number 9, right, seems like our y-intercept is right at 4. So y equals, I'll leave that blank, right, plus 4 at the end. Okay. What about the slope? Well, it looks like I'm going down 1 over 1. Or I could also be going maybe down 4 over 4. So let's write this down. So it's down 1, so it's negative 1 over 1. Or it could be written as negative 4 over 4. But really, negative 4 over 4 is the same fraction as negative 1 over 1. I just have to simplify that. And in fact, negative 1 over 1, right, before we said anything divided by 1 is just itself, so I could write that as just negative 1. The slope here is negative 1x plus 4. And even further, right, x times 1 is just x, so I can write this as negative x plus 4. And there's the equation of that line. Please pause the video now and go ahead and try number 10. Here we go. Answers are up in 3, 2, 1. Here are the answers. And here they are. You might have had something like y equals negative 4 over 1 x plus 0. Now just remember, if you divide by something by 1, it's just the same number. So negative 4 over 1 is the same as negative 4. And plus 0 really doesn't change the value of this equation, so we don't even have to write it. So we have y equals negative 4x.